In this video, we solve problem 9.2.083.mi from Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to use the formula for the nth partial sum of the geometric series shown below. Then we're told that the winner of a $6 million sweepstakes will be paid $300,000 per year for 20 years. The money earns 8% interest every year. The present value of the winnings is given by this formula. First, we're asked to compute the present value, and we're asked to round to 2 decimal places. We can evaluate this using this formula from right here. Now, we're also asked to interpret the meaning of this. In order to interpret the meaning, we need to think about present value of money and future value of money. The present value of money is the amount of money that is required to make these payments in the future. This is how much that you would have to have right now in order to be able to fund $300,000 per year for 20 years. So if somebody is giving you $300,000 per year for 20 years, if you multiply those together, you get the $6 million. So the person who actually wins, they get $6 million. But what this is saying is whenever you're calculating the present value is that the person who is funding that $6 million doesn't actually have to have $6 million in the bank right now, and then just to give you $300,000 this year and give you $300,000 next year and so on. They just have to have some amount in your account that will grow to the point that it's $6 million over that 20-year period, provided that it's earning 8% interest the whole time. Now, there's a lot more that goes into present value and future values of money than that, but we don't typically cover that in Calculus 2, and I'm definitely not an expert on it. It's been a little while since I've looked at present value and future value, but we can still evaluate this and understand what this means. Let me write it down. Present value is the amount we need now to fund the $6 million in payments over the 20-year period, provided that the entire time we have this money, it's earning 8% interest. That's given by this formula, and that formula can be derived in a class on finance or a class that covers a finance chapter. So that's how we're going to interpret it. Now, down here, they're just asking us to compute this value, and we can compute this value knowing what we know about Calculus 2. So basically, we want to take this sum and compare it to this sum and sort of match them up in some way. So we have the sum, as n goes from 1 to 20, of 300,000 times 1 over 1.08 raised to the nth power. So when n equals 1, we just end up with 300,000 divided by 1.08 to the first. And when n equals 2, we'll have 300,000 divided by 1.08 squared. When n equals 3, we'll have 300,000 divided by 1.08 cubed, and so on. And we keep going. And eventually we have 300,000 divided by 1.08 to the 20th, because that's going to be raised to the 20th power. Now I know that this is written slightly differently because you've got the fraction here, that to the first, that squared, that to cubed, and so on. But 1 to the nth is just 1. So I'm just going to have the 1.08 to the n in the denominator. So that's shorthand for this. Now, I want to write this a little bit differently because I want to write it in this form. Here, our summation starts with n equals 1, and I want it to start with I equals 0. So we're just going to label it a little differently. This was the n equals 1 term. This is the n equals 2 term. This is the n equals 3 term. This is the n equals 20 term. But instead of that being corresponding to n equals 1, I want it to correspond to I equals 0. And this I want to correspond to I equals 1. And this I want to correspond to I equals 2. And then since we're starting at I equals 0, rather than going from 1 to 20, we're going to go from 0 to 19. So I need to start with I equals 0 and go to 19. And then in this formula, we've got our first term times the common ratio raised to the I. The first term this time is that 300,000 divided by 1.08. That's our A. And our common ratio, oops, that should be raised to the I, is what we multiply by to get from here to here. Well, I'm multiplying by another 1.08 in the denominator, so I've got 1.08 in the denominator there, raised to the I. If you're saying, doesn't that look exactly the same as that? It's almost the same. This starts with n equals 1 and goes to 20. And then this one has a 1 over 1.08 to the nth. This one goes from 0 to 19. And I've got a 1 over 1.08 to the I plus 1. So somehow adding 1 over here allowed us to subtract 1 here and here. It's just because we're shifting. We're just labeling things a little bit differently. Okay, so given that this is our A and this is our R to the I, and then according to our formula, the nth partial sum of a geometric series is this. It's A, that's our first term, times 1 minus R raised to, not this power, that's the n minus 1 power. It's going to be raised to the nth power. We had 20 terms, so that's 20, all divided by 1 minus the common ratio. And so let me just write that formula off to the side. This is A times 1 minus R to the n, and in the denominator here, that's 1 minus R. So now we'll evaluate it. So you have 300,000 divided by 1.08 multiplied by 1 minus 1 over 1.08, quantity raised to the 20th. Close parentheses for that numerator. And then we're dividing by, open parentheses, 1 minus 1 over 1.08, close parentheses, and you get that number. And that's in dollars. And this is called present value. You might say, okay, well, what does that mean? That means that the person who is funding this $6 million sweepstakes, maybe it's like the state of Oklahoma is having a lottery and you can win $6 million in $300,000 payments spread out over 20 years. They don't actually have to have $6 million. They have to have nearly $3 million. They have to have $2,945,444.22. But as long as they have this much, they can give you the $300,000 payment the first year, and the $300,000 payment the next year, and the $300,000 payment the year after that. In over 20 years, they'll be able to give you the $6 million because the whole time, whatever is left in this bucket as they are making payments year after year after year is still accumulating 8% interest a year. So this nearly $3 million that we have is able to fund a $6 million sweepstakes because it's accumulating interest. Now, the more that you've paid out, the less interest it's accumulating. So if we were making, a if you had a $600 or a $6 million sweepstakes and you were going to pay it out in 2 years, $3 million this year and $3 million next year, that would be much more difficult. But the fact that we are making these payments over a 20-year period allows us to give them $300,000 and then have what's left over accumulating 8% interest, and then give $300,000 the next year and have what's left over accumulating 8% interest, and so on. As that amount that you have in this account gets smaller, the amount of interest that you're accumulating also gets smaller. But this is enough to fund a $6 million sweepstakes. That's the idea behind present value. So this says the $6 million sweepstakes has a present value of this amount, $2,945,444.22. That's how much they have to have to be able to pay that money. And then it says after accruing interest over the 20-year period, it will attain its full value. Now there's a lot more to present value than this. If you're wondering, where did that come from? That 1.08 has something to do with that 8% interest. That would be derived in a finance class or in a class that covers a whole chapter on finance and annuities and present value and future value.